Professor Abhay Karandikar, Director Sir Dr. Baldev Singh, Deputy Director Sir Professor Sylvie John, Memorial Lecture Series. We are here today to pay tribute to late Professor Jagdish Kumar Arora and to celebrate his legacy. I'm Sakshi, and it is a great honor for me to serve as the host for this illustrious gathering this evening. As they begin, I respectfully request the esteemed Director Sir to give a warm welcome to our honored chief guest and keynote speaker for the day by presenting him with a bouquet of flowers. Thank you so much, sir. To commence the event, I would now like to invite our highly regarded head of the electrical department, Professor Jagdish Kumar sir, to welcome all the distinguished guests and the audience member and give an overview of the J.K. Arora Memorial Lecture Series. A big round of applause for Jagdish.
Good afternoon. It is my honor to extend a formal welcome to our distinguished guests, including our acting director, Professor Baldev Sethia, Deputy Director, Professor C.V. John, Professor Arun Grover, all the enlightened members of the local chapter of IIT Kanpur alumni team, and most notably our honored chief guest director IIT Kanpur, Professor Abhay Karandikar, who has kindly made the journey to be with us today. Of the most illuminating addresses by highly accomplished and distinguished guests. The purpose of this lecture series is to inspire and educate young budding generations and to foster knowledge and understanding of cutting-edge technology. It is my sincere hope that each and everyone in the audience will take away valuable insights and knowledge from today's session. Thank you so much.
Thank you so much, Jagdish sir.
Professor Abhay Karandikar, our speaker today for this J.K. Memorial Lecture Series, and Director IIT Kanpur, Professor C.V. John, Deputy Director of the Institute, Professor Jagdish Kumar, Head of the Electrical Department, Professor Arun Grover, Professor Alvinder Singh, Director CSIO in the audience, esteemed members of the faculty, students, ladies and gentlemen. It's indeed a matter of honor and privilege for me to be associated with this memorial lecture. And here I take this opportunity to first and foremost welcome our chief guest today, Professor Abhay Karandikar from IIT Kanpur, an institute where I also feel highly attached. On behalf of the institute, on behalf of the Department of Electrical Engineering, and from the organizers of this J.K. Memorial Series, I take this opportunity to extend a very warm welcome to you, sir. Well, I also take this opportunity to pay my obeisance and reverence to late Professor Jagdish Kumar Arora. It's a befitting honor in the memory of the great professor who had also been an alumnus of this great institute. So for that I come forward to compliment the organizers of this J.K. Arora Memorial Lecture that they have put in all this effort, and we are here seeing and viewing the 7th edition of this memorial lecture. And for that, we have none other than the director of one of the top institutes, not only in the country, but internationally. For the benefit and information of our chief guest, and for some of you, let me tell you, we are passing through a very, very wonderful phase so far as this institute is concerned. In the recent past, we have seen that we crossed 100 years of our glorious existence. And we had the visits of 2 presidents of the country. First, in the year 2021, November to be precise, we had the visit of the then Honorable President of India, Shri Ramnath Kovind ji, and we started with our centenary year celebrations. And thereafter, in the year 2022, 9th October, we again had the visit of the Honorable President of India, the present President of India, Srimati Draupadi Murmu ji. And this is how we closed our centenary year celebrations, and we also had the convocation of the Institute. It was a year which was full of activities, one bigger and better than the previous one. We also had, in the month of December, one very big conference organized by one of the departments, Civil Engineering Department, and in line with that, today I find that there is a paradigm shift. I see a wonderful speaker, a very, very concurrent topic on which he is going to talk, and a full house audience. So that curve of our visitors that we had, it is receiving it's a paradigm shift, and we are extending it in a much better way. So that way, I believe the efforts of the department and the organizers, they are going to bring fruit. We are going to have the worth of our time and effort. Once again, I welcome our chief guest, our speaker, and welcome you all, and wish you a very happy time, a happy lecture. Thank you.
Thank you so much, sir, for your illuminating words. Moving on, it is my distinct pleasure to now extend an invitation to Professor Balwinder Singh, sir, to grace the podium and introduce to us our honored chief guest for the day, Professor Abhay Karandikar. Give a big round of applause for Professor Balwinder.
Good afternoon, everyone. So, Professor Abhay Karandikar is an Indian academician, engineer, and advisor, and best known for his work in the telecommunication sector in India. He is presently serving as Director of Indian Institute of Technology, Kanpur since April 2018. He is alpha mater. So, he obtained Bachelor of Degree in Electronics Engineering from Madhav Institute of Technology and Science, Shivaji University, Gwalior in 86. Then MTech and PhD in Electrical Engineering from IIT Kanpur in 88 and 94 respectively. He started his career joining with High Performance Computing and Communication Group at Center for Development of Advanced Computing, CDEC, Pune on Param 9000. He joined the Department of Electrical Engineering in Indian Institute of Technology, Bombay in 1997. At that institute, he held a very institute level position like HOD, Head Computer Center, Head Department of Electrical Engineering, Professor, First Professor in charge, IIT Bombay Research Park, and Dean Faculty Affairs. He has worked with the following in various capacities: Coordinator of Tata Teleservices, IIT Bombay Center of Excellence in Telecommunication, Coordinator of National Center of Excellence in Technology for Internal Security. He is co-founder and incubated Exodus Network in IIT Bombay's Business Incubator. He is advisor to several technology companies and government agencies in India and serves as a member in number of boards. He is one of the founding members of Telecom Standard Development Society of India and appointed as vice chairman and subsequently chairman of that society. He chaired the committee to give recommendation to Government of India on size, scope and quantum of spectrum for experimental spectrum license for 5G. So, conceptualization and establishment of new technology standards were programs for TSDSI. In 2016, he was awarded with IEEE SA Standard Medallion for his work to Indian technology policy and standardization with IEEE guidelines. He is a member for TRI and serves on the boards of Central Electronics Limited, CSC, Wi-Fi Protocol Services Limited, National Rail and Transport Institute, Science and Engineering Research Board, Indian Police Foundation, and Chairman, Board of Institute of Advanced Studies in Science and Technology, Guwahati. He also serves as member of Technical Advisory Committee of Security and Exchange Board of India. Sir has contributed in telecom policy and regulations that were included in national level telecom policy. He has been the chairman of committee set up by the Ministry of Defence in 2018 for preparing a roadmap for development of indigenous software-defined radio ecosystem. He is the chairman of Defence Standard Development Authority set up by the Ministry of Defence based on recommendation of the committee. The sir has vast experience in policy making and standardization in telecommunication and recognized at international level. He has been elected as vice chairman of a third generation partnership project program coordinator group in 2016. He has done the projects like Grammar, his team developed the technology in IIT and set up India's first TV white-based test bed in 7 villages and rural broadband pilot in 25 villages covering 100 square kilometers in Palghar district in Maharashtra. His Grammar solution for rural broadband was the winner of Mozilla Open Innovation Challenge in 2017. He has also worked on the concept of FRUGAL 5G for rural broadband, and his research team has initiated a standardization activity under FRUGAL 5G working group in IEEE. So his group has made many fundamental contributions in the field of wireless communication, especially in resource allocation in next generation heterogeneous wireless network, software-defined networking, and network function virtualization. Sir has been recognized by the Government of India and private organizations on several occasions for his meritorious research work and research projects. Sir has several patents in telecommunication networks to his credit. So today, Sir will share his valuable insights and some of the findings with us on the hot and trending topic FRUGAL 5G network towards IEEE 52061 standard. Certainly, the audience will be enriched with the knowledge of future communication mode. Thank you for listening patiently. Thank you.
Thank you so much, sir, for that wonderful introduction. I'm sure that today's talk will be not only insightful but enriching for all of us present in the audience members. I would now like to invite Director Sir and HOD Sir to bestow upon our honored Chief Guest of the day a symbol of gratitude in the form of a memento and a gift as a token of appreciation. Thank you so much, sir. I would now request all the dignitaries to please join the audience members and be seated on the front row seats. Give a big round of applause for our guest for the day.
अबे क्या कर रहा है? पागल है यार तू। मैं पहले आना मत।
आप बुला लेना ना, फिर वो पीछे एडजस्ट होंगे क्योंकि इवेंट को स्टार्ट हो जाएगा।
Of the base station, because the base station is driving the power from the power grid, and it was never thought that you have to make the energy efficient base station. But that is not the situation in a country like India. We want to have a base station which will give a very high spectral efficiency at maybe 50 watts and working at 50 watts or 100 watts and not at half a kilowatt. So this actually changes network, and I just thought it would be quite appropriate to introduce all of you when India is going to launch the 5G network, that what work we have been doing in this area. In fact, I was in Delhi just last 2 days. I serve on the board of governors of IEEE Standards Association. I'm the only Indian there on the board, and this time we were holding the board meeting for the first time in India. And so I was in Delhi, and we are driving this standard P2016. There is a related standards IEEE 1930, which was recently approved, and that is the first IEEE standard came out of Indian efforts, and that was primarily led by our research group. This standard actually builds on the 1930 standards, and I will briefly mention even that as well. So this is a brief agenda. I will briefly tell you that what are the key challenges for what we called as connecting the unconnected. Okay, and from that have flown certain key requirements, and we have come up with several solutions in that. In fact, this is a topic on which our research group has been working for last 10 years, and we have made certain fundamental contributions both in terms of intellectual property rights, IPRs, standards, essential patents, technology, and finally global standardization efforts as well. So if you see the global internet connectivity status, so despite the talk that it is often now cliche to say that we have an explosive growth of cellular mobile wireless communications, we have billion plus cell phone subscribers, but the fact remains that despite this significant growth in cellular mobile communications in particular and wireless communications in general, 32% of the population is still unconnected. And majority of this population in developing world, and most of that lives in rural areas. Even in India, we have a very large addressable market where we have not reached the true broadband. I mean, as all of you know that even in tier 1 and tier 2 cities, we often have difficulties in accessing, what I call as the true broadband. But even in the rural areas, we have even more problems. Despite, in the recent years, we have seen significant broadband penetration. The pandemic has only reinforced the need for improved connectivity. In fact, during COVID-19 time frame, we needed this digital connectivity even more, and obviously that had problems. I'm sure many of you would have faced this problem when the classes were completely switched to the online mode. There was an issue of continuous broadband connectivity, and in tier 2, tier 3 and rural areas, this problem was even more acute. Now there are several use cases for rural connectivity, not only for the online education, but even for the healthcare services, access to citizen services, access to banking and finance, and facilitating the small businesses, etc. Now, if you do not have the broadband connectivity, then in some sense we are creating a digital divide between haves and have-nots. One who have access to digital connectivity and thereby better access today to healthcare, online education, banking and so on, and other class which don't have access to these. Now let us understand what are the issues and why it is happening. Now if you look at the developed countries, in the developed countries, the internet is mostly enabled through the wired infrastructure, that is fiber or DSL or cable. The fiber goes to the home, and then in the home you can have a Wi-Fi, and you can get actually a gigabit speed at home. And then of course, inside the home you can get connected to the Wi-Fi. And this is the same situation even in the enterprises. But in developing countries such as India, cellular technology became the primary broadband access mechanism. Now, one has to look at it historically, because the cellular mobile communication was evolved to address the mobility needs earlier. So as I said, that in the developed countries, everyone was having access to the voice communications and to the broadband communication, and they needed the communications while they are on the go. So while you are in the car or you are in the train and so on, and that is why the cellular mobile communication was invented in late 80s and early 90s. But in countries such as India, the cellular mobile communication became the primary phones for a large number of people for the voice communication, and later on when the 3G and the 4G came, it became the primary device for accessing the broadband communications. And that is where the problem lies. Now, while cellular infrastructure is much easier to deploy, but is cellular enough? Now, the challenges were that as the technology of the cellular mobile communication was invented and was evolved, the focus of the technology was more on the urban usage scenario with mobility, there was a limited support for the rural connectivity requirement in the specification. When you deploy the cellular mobile technology, there is a limited incentive also for the operators to deploy this technology in the rural areas, and I will shortly tell you that why it is unattractive for an operator to deploy in such areas. And as a result, it leads to the slower deployment in the rural areas and consequently therefore the lower data rate. Now what are the challenges? Some of the challenges are these. One is that in the rural areas the population may be sparsely sort of populated, as is shown here in some of these maps. These are not typical to only Africa or India, but even in other countries and continents it may be similar. That means you may have clusters of population, and then for a then there may not be any inhabitants for some few kilometers, and then again there are clusters of houses and so on. Okay. There are of course remote and difficult to reach regions. So there may be like a hilly area or terrain is very difficult, and these are not all, but a significant percentage of the rural area technologies. I told you that in our Palghar experiments we used the TV UHF band at at 500 megahertz, but you could use long distance Wi-Fi link. You could use, for example, free space optics, or you could use terrestrial microwaves, or you could even use the satellite links, and you can also use integrated access and the backhaul, IAB, which is getting now standardized as a backhaul the traffic from the mobile tower to the core networks. So if an operator wants to deploy large number of cell phone towers, the operator needs to provide a backhaul connectivity to these towers, right? So for every wireless, you definitely need a wire. And there is a cost in terms of laying the fiber and also the right of way. Okay, so there is a significant cost of the backhaul network. Then there are scarcity of resources. In some of the rural areas, you may not have 24/7, 365 days electricity. So therefore, the operators typically at the mobile towers have the diesel generator sets. And this not only adds to the environmental pollution cost, but also forms a significant percentage of the operator's revenue in terms of expenses on the fuel cost. Okay, so that is another sort of thing. And as the base stations are evolving, like from 3G to 4G, the power requirements are also going up. So it is not actually easily possible to have a solar panel feeding the power, because the power requirements may be half a kilowatt, okay, of that high. And sometimes base stations may require air cooling or an air conditioning as well. So the overall power requirements are significant. You really can't have a renewable energy source like a solar panel on the mobile towers feeding that, because if you really want to generate half a kilowatt of power, then you need significant area. There is a low average revenue per user for an operator. Now this is very interesting. Per user, of course, all of you, who are accessing the mobile broadband, as you know that India is a very cost-sensitive market. Every user may be paying just 100 or 150 rupees per month. Okay, and with 150 rupees average revenue that is there, of course, some users may be paying 500 rupees or 1000 rupees, but average revenue per user in India is about 150 rupees per user per month. Now with this, if the number of subscribers is less, then the operators are not able to make a business sense out of that. Okay. For example, a big operator in acquiring the customer itself may have to spend something like 3,000 rupees or so, because there is a cost of centralized software for database and customer management, etc. If you amortize that cost over the number of subscribers, it will come out to be something like 3,000 to 4,000 rupees per subscribers. Now, if you are paying just 100 rupees per month, then it will take 3 years to just recover the cost of acquiring you. Forget about the cost of the spectrum and the cost of the network itself. Then there are access constraints in terms of right of way. If you want to lay the fiber, then you need to have access to the land. So sometimes, in rural areas, these lands may belong to the private users. Okay, so they may not permit, digging the roads and so on. Okay, so there are right of way issues. There are challenge of manageability. Often in these areas there may be unavailability of trained manpower, which can be used to sort of run and manage the network. And finally, the relevance of content. Most content on the internet is in English, and only a handful is available in other languages, although the situation has changed recently, and we do have a content in Indian languages as well. So, when the 5G standards were defined in year 2012 or 2014 timeframe, we started rethinking some of these requirements for the 5G. That how do we make the 5G network suitable for, let's say, Indian rural requirements. So one is, of course, you have to reduce the cost of the network. So you need a low cost solution. Okay. So in the low cost solution, there are two things. One is you have to reduce the cost of the backhaul networks. So I said, the backhaul is increasing because you have the fiber. So can we have the wireless backhaul instead of the fiber? So that way, you can reduce perhaps the cost. You have to reduce the cost of the spectrum. So can we use the unlicensed spectrum wherever possible? Okay, so that is also sort of another way. We need limited mobility support. Remember that many of you are using the cell phone as a primary broadband access mechanism. And as I told you, that the Western world was evolving the technology to address the mobility requirements. So when the standards discussion was going on to go from 4G to 5G, in the 5G, they said that you need very high speed mobility, like 300 kilometers per hour and 500 kilometers per hour. That was the mobility requirement. That means, you can watch a YouTube movie while you are in the bullet train. Okay, that is the requirement. While all of us, we needed the high throughput and high bandwidth when you are fixed and nomadic. And in Indian cities, most of the time, you will not be driving at more than 40 to 50 kilometers per hour. So we need mobility, but we don't need very high speed mobility. Now there is a trade-off in the technology. What happens is that, of course, something which is working at 500 kilometers per hour or 300 kilometers per hour will also work if it is at 0 kilometers per hour, if you are fixed, but at a huge cost in terms of energy efficiency. So a device which you have made to optimize and tune for a moderate or a high speed mobility, if the same device you use only for the fixed access, etc., then the energy efficiency will be very low. Maybe you will have to really recharge your battery several times, and the same thing is will be true even for the base stations. Or alternately, you may not be able to get that kind of a spectral efficiency when you are at the fixed axis. So therefore, you have to really set your requirements. That what is your requirement? Whether you want a very good spectral efficiency and a very good energy efficiency when you are fixed and nomadic, or whether you want very good energy and spectral efficiency when you are a high-speed mobile. So these are contradicting requirements, and when the 5G requirements were defined, the focus was more on high-speed mobility, which was really not the focus in terms of Indian conditions. Okay, so that is number one. Another thing is that you needed a large coverage area support. For example, if you have to cover a very large rural areas, then you need a base station whose radius can go up to 3 kilometers or 4 kilometers. Okay, so that was also another requirement. The other requirements were energy efficient solution. By energy efficient solution, remember that in the wireless communications technology industry, so all the researchers in the wireless communication, I mean, if you look at any of the research activity in academia or in the industry, energy efficiency is always focused on the energy efficiency of the cell phone, because you develop signal processing algorithms, you develop processing algorithms to make the cell phone battery last longer, to make the cell phone smaller and sleeker. But in the Western world, there is never a focus on the energy efficiency of the base station, because the base station is driving the power from the power grid, and it was never thought that you have to make the energy efficient base station. But that is not the situation in a country like India. We want to have a base station which will give a very high spectral efficiency at maybe 50 watts and working at 50 watts or 100 watts and not at half a kilowatt. So this actually changes the requirements significantly. You want high spectral efficiency when you are at a fixed axis or a nomadic axis. You want the base stations to work with very high energy efficiency, so that the power requirements of the base stations goes down. Of course, you also want the cell phone also to be energy efficient, but at the same time, you want the base station also to be energy efficient. So these were therefore the requirements, that you want affordability, you want clustered service provisioning, you want that you can use the renewable energy, you can allow the localized communications, you want limited mobility, you want connectivity to remote areas, and so on. So I think these were the requirements that we designed, and then we took up to the global standards body, which is IEEE, and this is how the IEEE standards P2061 activity started. Now this P2061 standard provides an architecture for affordable broadband access with a large coverage area and low mobility and energy efficiency. So actually this is an architecture, this is a 5G network architecture which will give you an affordable, energy efficient and a low cost network deployment. So this was actually the standard, and I will now briefly talk to you about the standard itself, which we are drawing, which we are leading. Now, initially, in fact, you can refer to this IEEE Communications Standards magazine paper, which appeared in June 2020, which we had authored, that connecting the unconnected towards frugal 5G network architecture and standardizations. Now, before we started working on this, we experimented with several ideas, and we actually deployed this light testbed in Palghar district near Mumbai. So this actually articulates that how one can do the deployment of a very low cost and energy efficient architecture for providing the broadband internet. So as you can see here, the idea was that you have a shown here, on this is a Tata Tele Services TTSL tower, the mobile broadband tower, and several of the villages which were located around this tower and which are shown here, for example, the Bahadoli village or Bhuptan village or Khamloli village. In all these villages, we set up the Wi-Fi hotspots. Okay, so we have set up these small cells or the Wi-Fi hotspots. In fact, about 65 such Wi-Fi hotspots were set up. Now, there was no fiber or there was no cable to these Wi-Fi hotspots. So therefore, these Wi-Fi hotspots needs to be backhauled. That we called, and I will shortly tell you, as the middle mile. That needs to be backhauled to wherever the fiber point of presence is there. And for that, we use the wireless middle mile, because you can't take fiber to each and every Wi-Fi access point, because that would have been very, very expensive. Okay, so we use TV UHF band, which is 470 to 594 megahertz. The advantage of using this lower frequency band is, as you know, that lower is the frequency, longer is the wavelength, and therefore it can have a better propagation characteristics. So therefore this UHF band can cover the large distances and also can provide near line of sight communications, and therefore this is a good band for backhauling these Wi-Fi access points to the point of presence. Furthermore, you can actually tweak the Wi-Fi which works at 2.5, 2.4 or 5.8 gigahertz to make it work at 500 megahertz by simply upscaling the RF, and you can actually reduce the power consumption significantly to sub 100 watts. Okay, so as a result, you can use this as a wireless backhaul, and of course, as I mentioned, Wi-Fi for access in the villages. So we did this experiment and we found that we were able to provide the broadband connectivity to large number of villages using the very cost-effective technology, and we thought that this may be a starting point for developing a frugal 5G standard. So here is how the P2061 architecture came up. So this architecture, this is a very high level architecture. So this architecture states that there is an edge, okay. So here is this middle mile. Here is this middle macro base station, which is shown here in the diagram, where there is a fiber point of presence. The fiber terminates at a certain macro base station, and you have to cover the villages which are around it. Now, this is a very typical situation in the Indian scenario, where the fiber goes to each gram panchayat, and as you know that in India 250,000 gram panchayats are there and about 6 lakhs villages are there. So there are about 2 to 3 villages in each gram panchayat. And Government of India, for example, is having this BharatNet project where you take fiber to each and every gram panchayat. So in the macro base station, here is a fiber which terminates at the gram panchayats, and then the nearby villages you need to serve. So as is shown in this diagram, that these nearby villages, you have the WLAN access point, that is the Wi-Fi access point based small cells, which can provide the high-speed connectivity, and all these small cells are backhauled using the middle mile network, as is shown there, the middle mile network to provide the wireless backhaul, and the macro base station is providing an umbrella coverage. So this macro base station, for example, could be an LTE 4G network, or this could be even 5G NR networks. So as a result, what happens is that when you are fixed or stationary, you access the internet using Wi-Fi. but when you become mobile, then you get offloaded to the 4G or the 5G base stations. Of course, small cells could be even the 4G LTE small cells also, or they could be the 5G small cells as well. Now, there are certain things that are needed because, as you know, that we had set our target of providing energy efficient, accessible, and a low-cost broadband access networks. So therefore, certain innovations are needed. But before I go to that, so there are certain fundamental principles. One is that we provide an umbrella coverage using a large coverage area support, which can provide the ubiquitous connectivity. Then these are small cells or the hotspots, which work in clustered fashion, which are high-speed access points. There is a notion of wireless middle mile to backhaul the data, so there is no fiber being used now in the middle mile. And of course, there can be some point-to-point wireless link as well to connect the nodes in the villages. Now, so basically, we have majorly introduced the notion of a middle mile. So there is an access networks, there is the wireless middle mile, and there is the core or the backhaul networks. And this typically is gels very well with an Indian example where the optical fiber terminates a few kilometers away from the villages, and middle mile can be considered as the extension of the optical point of presence to the villages. And these are Wi-Fi access points in the villages to provide the broadband connectivity. And I just mentioned that these Wi-Fi access points in the villages get connected to the fiber point of presence. Now, there are several middle mile technologies. I told you that in our Palghar experiments we used the TV UHF band at 500 megahertz, but you could use long distance Wi-Fi link. You could use, for example, free space optics, or you could use terrestrial microwave, or you could even use the satellite links, and you can also use integrated access and the backhaul IAB, which is getting now standardized as a part of the 5G networks. Okay, so you can actually use a combination of this. But the key idea is that you don't have to take fiber to each and every base station. You can actually use a middle mile technology to reduce the cost of the backhaul networks. And of course, you need to do some capacity planning to see that your overall cost is optimized. I mean, I have not gone into the details of a network optimization and capacity planning. Now, this network requires to be controlled. So just to give you an example of this, when we introduce this middle mile, and when we are having the Wi-Fi access point, and when you are using the macro base station like an LTE 4G, in today's network, if you deploy, it will be extremely complex, okay? Because the Wi-Fi access points would require a separate Wi-Fi controller, okay? The LTE 4G base stations requires a core where there will be a separate controller, and the middle mile also requires a separate controller. So, in fact, it would only increase the complexity, and plus the edge will currently, doesn't have any intelligence, and as a result, the Wi-Fi access points need to be intelligent devices. So that actually can increase the cost. Now, we don't want to do this. What we want to do is that we want to deploy this network using a very dumb Wi-Fi access point. So the entire intelligence will reside at the edge. That is number one. Number two is that we want to make sure that the 4G or the cellular mobile network, the middle mile and the access point, they all get controlled through a single controller. Okay, and that is where we introduce the notion of an edge controller, So we are providing a very flexible implementation where we can use the combination of the macro cell and the Wi-Fi access point. We bring intelligence at the edge, and by bringing intelligence at the edge, we will see that we can enable the localized communication as well as the direct internet connectivity without going through the core. So for example, today, as you know, that if you are sitting here and if you want to talk to each other, even in the same room through the cell phones, your traffic needs to go to the entire core networks and needs to get routed. But it is possible to do the localized communication by introducing the intelligence at the edge as well. And finally, we introduce the SDN-based unified control. Now, this provides an architecture which is getting now standardized. Now, in this architecture, what we have done is this is a cloud-based core network which does an overall control of the network, and then not sure whether this mic is working. And we have at the edge a hierarchical software-defined networking-based control because, as you know, that there are now multiple radio access technology. There are these Wi-Fi access points, there are these wireless middle mile, and there are these 4G networks. So therefore, we need a unified control of this, and this unified control is being provided through an SDN controller. And of course, we need synchronization of network functions over edge and cloud. Now, what innovation we have done here is, there are these base stations are there. There are these Wi-Fi access points is there. There is middle mile is there. There is LTE 4G is there. There are these 5G base station could also be there. We have introduced the innovation of abstracting the resources of these physical base stations into the virtual base stations. Okay, so we introduced the notion of what we call as RAD specific control function, that is radio access technology specific control function. So this RAD specific control function actually provides an abstract view of the underlying radio to the higher level entities. And then in the RAD agnostic control function, so for example, if you take any network, whether it is 3G or 4G or 5G or 2G, you need mobility, you need security, you need implementation of certain network level policy, you need user databases. These functions are there in all networks, whether it is Wi-Fi or whether it is LTE or whether it is 5G. So basically, it is possible to devise a mechanism that you have these protocols and functions which are independent of the radio access technologies. And the radio access technologies only work on the physical layer aspect. So basically, it is possible to abstract out these resources, convert them into the virtual base stations, and work on these virtualized resources. This will actually enable a very scalable implementation of the networks. In fact, this concept, we are now taking it into designing a beyond 5G networks as well, independent of the frugal 5G. Because what we are saying is that whenever an operator deploys a network, the operator simultaneously has a 3G network, has a 4G network, has a 5G network. Today, whenever an operator deploys a network, the control of the network is separate. Okay? And therefore, if you want to switch from 4G to 3G, it is not possible to seamlessly switch from one network to another without breaking the call. Okay, a seamless switching from the LTE to Wi-Fi or Wi-Fi to 5G, it is not possible. Okay, this concept of virtualizing the radio resources and then controlling them through a software-defined networking function can actually enable the multi-radio access technology control of the operator in any heterogeneous networks. So this is the concept that we have introduced into this standard, and as you can see here, the standard also defines the interfaces between two radio access control functions. It defines an interface between an SDN controller and radio specific control functions and so on. Now, finally, let me just tell you that today, for example, what happens if you have an LTE, if you have a Wi-Fi, if you have a 3G, then today the standard defines inter-networking functions for each of these. And at the core network at the operator, you would have a controller for all of them. And then in the back end, there will be a controller which will be used to switch the network from one function to another. We have eliminated that. We have, by introducing an SDN switch and controller in the access networks, and this introduction can actually provide a unified RAN level control, a unified radio access network control and management at the operator level. I don't want to go into the details of this. All I can say today is that, for example, if you have a cell phone and if you want to connect to the internet today, you have to go through the operator's core networks. However, this kind of a technology can actually provide the cell phone's connectivity directly with the internet without going through the core networks, because the cell phone's connectivity with the radio access network is now decoupled from the cell phone's connectivity with the core networks. And this way, you can just treat these radio access as just one of the radio technologies. Finally, I just wanted to mention here that although the P2061 architecture, we are calling it to be sort of a frugal 5G network, this can also work with the 3GPP 5G network as well. In the 3GPP 5G network, as I mentioned, that the macro base stations could be a 5G network. Okay, so it could be a 5G NR, which is providing an umbrella coverage, and you can use a combination of multi-rad radio access technology control to control the 5G base station as well. So this actually provides a significant scalability. So some of the key points I would like to just mention here that we have introduced the notion of software-defined networking to decouple the RAN from the core, that is the radio access network from the core. We are architecting a very flexible mobile network architecture where any radio access technology can be used with any core, and of course there are other use cases like we can provide direct connectivity to the internet, we can have a non-standalone implementation, and we can have a captive networks. For example, if you want to deploy using the wireless technology a network here, you don't really need a complex core of an operator. You can deploy a network here as well. So we had set out some of these requirements. So how do we achieve affordability? We achieve the affordability by deploying these Wi-Fi access points as a small cells in large numbers. Okay, so that is number one point. And number two is that since these Wi-Fi access points are consuming maybe only 10 to 20 watts of power, we can actually reduce the overall energy requirements as well. Now, these Wi-Fi access points require the connectivity to the fiber point of presence. So we introduce the notion of a wireless backhaul. So that can also reduce the cost of the backhaul networks. However, introduction of this introduces complexity in the network, but as I mentioned, that we can address the complexity by introducing the notion of software-defined networking controller, and by introducing intelligence at the edge, you can actually enable the local content generation and storage as well. So these are some of the innovation. I mean, of course, I have talked only at the broad level. Those of you who work in the networking domains, you can find more details of this in some of our work. You will find the papers on my website. So what is the status of this standard? So this standard called Architecture for Low Mobility Energy Efficient Network for Affordable Broadband Access. The standards define the mobility needs earlier. So as I said, that in the developed countries, everyone was having access to the voice communications and to the broadband communication, and they needed the communications while they are on the go. So while you are in the car or you are in the train and so on, and that is why the cellular mobile communication was invented in late 80s and early 90s. But in countries such as India, the cellular phone, when the 3G and the 4G came, it became the primary device for accessing the broadband communications. And that is where the problem lies. Now, while cellular infrastructure is much easier to deploy, but is cellular enough? Now, the challenges were that as the technology of the cellular mobile communication was invented and was evolved, the focus of the technology was more on the urban usage scenario with mobility. There was a limited support for the rural connectivity requirement in the specification. For an edge element, and we can actually go for a very, very scalable architecture. As I already mentioned, that 2061 standardization is currently ongoing. We expect to complete by this year. I just wanted to mention here that we are not developing any new radio technology. So we are not developing something, so Frugal 5G is not something that this is a new kind of a Wi-Fi or a new kind of a 5G or a new kind of an LTE network. This is a technology which is using the existing radios, which could be like a Wi-Fi, or this could be like an LTE, 4G, or
high internet broadband services through satellites. So I was wondering, what is your viewpoint on India's inclination towards providing internet through satellites in future, and also its frugality and also other aspects?
Yeah, absolutely. I think in fact there will be a possibility to provide internet connectivity through satellites. Also, we may use other platforms like high altitude platforms, HAPS, or the UAVs. So as more and more radio access technologies come, you need a scalable way of integrating them. And in fact, we have a paper which will tell you that how our architecture can actually provide a scalable way of integrating these technologies. So as I mentioned that I don't work on the particular radio access part. So radio could be coming through satellite, or it could be a radio on the UAV, or it could be some other radios as well. But when you have internet which is to some areas it is provided through satellites, to some through UAVs,
some are having Wi-Fi access point, and some are having 5G or 6G, and all is being done by an operator, then you need a scalable way in the back end to integrate that. And so if you are currently now accessing the internet through satellite, but if you enter inside a home and you are in the basement and then you get connected to Wi-Fi, then your connection should last seamlessly. So today, the architecture, the network architecture, it is not possible. Your connection will definitely break if you switch from one access networks to another access networks. And what some of the concepts that I have provided, that you virtualize each of these resources and then work on the virtualized resources rather than controlling directly the physical resources through a software-defined network which separates the control and data plane. You can actually scale the architecture. But yes, the satellite network is definitely a possibility in the 6G.
Isn't it better to make India fully 4G first, then go to 5G, or is it better to make it first 5G? Like in a very famous game of Clash of Clans, there is a town hall and we make all the buildings first fully upgraded to the maximum level according to the town hall, and then upgrade the town hall. So isn't it better to make it first fully 4G?
We may go for another generations maybe 10 years later. So for next 15 years we may have 2 more generations. So I think
the second is the usage ultimately remains the same. People use it for not for education purposes, they use for either communication or entertainment. So what is the content that is deriving better quality of communication?
yeah. So I think again I did not touch upon that aspect, but I just wanted to say that 5G is a paradigm shift. When I see as a wireless scientist, it is not just increased throughput or increased speed. 5G actually provides many more features of what is called as ultra reliable low latency. It has also a feature of machine to machine communications. So this ultra reliable low latency feature can actually enable many of the AR and VR applications, that is the augmented reality and virtual reality applications, in a manner which we have not even thought now. So once the 5G deployment happens, it is likely that you will have applications and use cases which we have not even thought of. Today's application, as you rightly said, that is 5G just an increased speed over 4G? The answer is no. Then what is it? Well, as of now, I will only think that by using a 5G, I can download a YouTube movie faster, or I can view on a Netflix in a much more better way. But 5G has many features which will open up the possibilities of applications and use cases which we have not thought of. Okay, so for example, no one could have predicted that we would have a Facebook or a Twitter or an Instagram or a Google. You don't know after 5 years down the line, by exploiting the features of ultra reliable low latency and MTC kind of communications, what kind of applications and use cases we will have. By the way, in this context, I must say that if you would have read the present budget of the finance minister has announced the setting up of 75 labs or 100 labs in the country for focusing only on the applications and the use cases in some engineering colleges, institutions and academic institutions. And I consider it to be a very significant move because I believe that our young populations and entrepreneurs can come up with ideas to exploit these 5G technologies to develop applications and to develop scenarios which we have never thought of. As of now, I just see that
usage ultimately remains the same. People use it for not for education purposes, they use for either communication or entertainment. So what is the content that is deriving better quality of communication?
Yeah, so I think, again, I did not touch upon that aspect, but I just wanted to say that 5G is a paradigm shift. When I see as a wireless scientist, it is not just increased throughput or increased speed. 5G actually provides many more features of what is called as ultra reliable low latency. It has also a feature of machine to machine communications. So this ultra reliable low latency feature can actually enable many of the AR and VR applications, that is the augmented reality and virtual reality applications, in a manner which we have not even thought now. So once the 5G deployment happens, it is likely that you will have applications and use cases which we have not even thought of. Today's application, as you rightly said, that is 5G just an increased speed over 4G? The answer is no. Then what is it? Well, as of now, I will only think that by using a 5G, I can download a YouTube movie faster, or I can view on a Netflix in a much more better way. But 5G has many features which will open up the possibilities of applications and use cases which we have not thought of. Okay, so for example, no one could have predicted that we would have a Facebook or a Twitter or an Instagram or a Google. You don't know after 5 years down the line, by exploiting the features of ultra reliable low latency and MTC kind of communications, what kind of applications and use cases we will have. By the way, in this context, I must say that if you would have read the present budget of the finance minister has announced the setting up of 75 labs or 100 labs in the country for focusing only on the applications and the use cases in some engineering colleges, institutions and academic institutions. And I consider it to be a very significant move because I believe that our young populations and entrepreneurs can come up with ideas to exploit these 5G technologies to develop applications and to develop scenarios which we have never thought of. As of now, I just see that
4G took a lot of time, and then now transitioning from 4G to 5G is taking some time. How do we see a current infrastructure that is being deployed for 4G and 5G will be useful for 6G that will
versus 5G? Okay, so so it is not, for example, whether it should be 4G, 5G or Wi-Fi. Okay, you can enable Wi-Fi access points also for everyone, and that should work quite well. Okay, because Wi-Fi can give you today, the Wi-Fi standards can give you a gigabits of speed also. And if you are just using the internet sitting here, then Wi-Fi will also work very fine. So I don't think it is an issue of 4G versus 5G versus Wi-Fi. These are various radio access technology evolution, and the deployment, how these needs to be deployed, whether you need to deploy only 4G first, or whether you have to stop 4G and whether you have to deploy only 5G. This is a question that needs to be decided based upon the business case and the return on investments by the operator. So suppose in a city you don't have even 4G and an operator wants to deploy the networks, then the operator will ask this question whether you want to deploy 4G LTE or whether you want to leapfrog and deploy directly the 5G. Okay, what makes the more business sense. So these decisions are primarily driven by business and not merely by the technology. But the fact remains that once you deploy the technology, there is a cost associated with it, and you need the technology evolutions in such a manner that the cost needs to be minimized. The one way in which we can minimize the cost is to make the core network same, whatever be the radius. Whether it is Wi-Fi or whether it is LTE, whether it is 5G, the core remains the same. If that is same, then we can actually plug and play various radio access technologies. So I think our research is actually toward making a scalable core which doesn't have to be changed irrespective of the radio. So I think that is, but whether I should only do 4G first and then go to 5G is a decision which needs to be taken by the Geos and Airtels of the world. Versus 5G. Okay, so so it is not, for example, whether it should be 4G, 5G or Wi-Fi. Okay, you can enable Wi-Fi access points also for everyone, and that should work quite well. Okay, because Wi-Fi can give you today, the Wi-Fi standard can give you a gigabits of speed also. And if you are just using the internet sitting here, then Wi-Fi will also work very fine. So I don't think it is an issue of 4G versus 5G versus Wi-Fi. These are various radio access technology evolution, and the deployment, how these needs to be deployed, whether you need to deploy only 4G first, or whether you have to stop 4G and whether you have to deploy only 5G. This is a question that needs to be decided based upon the business case and the return on investments by the operator. So suppose in a city you don't have even 4G and an operator wants to deploy the networks, then the operator will ask this question whether you want to deploy 4G LTE or whether you want to leapfrog and deploy directly the 5G. Okay, what makes the more business sense? So these decisions are primarily driven by business and not merely by the technology. But the fact remains that once you deploy the technology, there is a cost associated with it, and you need the technology evolutions in such a manner that the cost needs to be minimized. The one way in which we can minimize the cost is to make the core network same, whatever be the radius. Whether it is Wi-Fi or whether it is LTE, whether it is 5G, the core remains the same. If that is same, then we can actually plug and play various radio access technologies. So I think our research is actually toward making a scalable